Hey everyone, welcome to yet another interesting and informative video by Simplilearn. Today's video will teach us all about circular singly linked list in C. But before we begin, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. So now, without any further delay, let's begin. This session will help you understand what a circular singly linked list is in C. After that, let's understand the memory representation of a circular singly linked list. Later, let's look at the syntax and finally, operations performed on a circular singly linked list. So before we get started, I have a simple question to you guys. Please try to answer in the comment section below and we will update you with the correct answer in the chat section. And the question is, the tail node's address is pointing towards the head node of the linked list. What is the name of the linked list? That means the last node's address is pointing towards the first node of the linked list, and guess the name of the linked list. And the options are singly linked list, doubly linked list, circular linked list, or both singly and doubly linked list. Please try to answer in the comment section below. Alright. Now, let's begin by understanding what a circular singly linked list is in C. In a circular linked list, we can perform a circular singly linked list and circular doubly linked list. So this session is on a circular singly linked list. In the circular singly linked list, there is no null in any of the nodes. Instead, the last node's next pointer holds the address of the first node. So basically, there is only one pointer variable in the circular linked list. And the traversal of a circular linked list is until we reach the same node we started in a list. Moving ahead, let's have a look at the circular singly linked list memory representation. So first, let's consider 4 elements to be inserted into the list. And for that, we have 4 nodes, where each node consists of data part and address part stored at some address 2000, 2016, 2022 and 3000. In the singly linked list, the last node points to null. But when we compare a circular linked list with singly linked list, we don't find a null. Which means, in a circular linked list, the last node's next pointer holds the address of the first node. In other words, we can say that the tail node's address is pointing towards the head node of the linked list. And as I discussed before, every node in a linked list is connected with the other through a pointer that points to the address of the next node. And that is represented by the arrows in this diagram. For example, so let our elements to be inserted be 10, 20, 30 and 40. As you all can see, the last node next is holding the address of the first node, that is 2000. And the next part of the first node is holding the address of its next node, that is 2016. Similarly, the second node is holding the address of its third node, that is 2022. And the third node is holding the address of its next node, that is 3000. And the last node is holding the address of the first node. And in this way, they are linked together. Up next, we have a syntax of a circular singly linked list. The syntax of a circular singly linked list is similar to that of a singly linked list. So, we have a struct keyword followed by a structure name called node. Then, we have a variable's declaration, that is data and struct node asterisk next, a pointer variable pointing to an element of a structure node. So with this, let's try to execute a simple circular singly linked list program to understand in a better way. So in this program, we have a pointer variable called next, and inside the main function, we are creating nodes, and they are first, second, third and fourth. So for every node, we need to allocate memory for it. So using malloc function, we are creating memory, or we are allocating memory for it. And once allocating memory, we are inserting values into it, and the elements are 10, 20, 30 and 40. And once inserting value, we need to link each and every node. So for that, first next is holding the address of second node, second next is holding the address of third node, and third next is holding the address of fourth node, and the last node, that is fourth node next, is holding the address of its first node, and last is equal to fourth. And display function will display all the elements in a circular singly linked list. So it first checks the condition. If the last node is equal to null, then the list is empty. Pointer is equal to last node's next, do. So it checks the condition. It prints the values, that is pointer's data. It prints the data of every node and then checks the condition while pointer not equal to last node's next. So now let's try to execute. And here we got the output. The elements are 10, 20, 30, 40 inserted into a circular singly linked list. Okay, so now let us move on to the operations on a circular singly linked list. First, we have the insertion operation. Next, the deletion operation. And finally, the traversal operation. Let's understand them in detail. Under insertion operation, we have insertion at beginning. So basically, we insert the elements at the beginning of the element list. Next, insertion at the end. That means it inserts the element at the end of the element list. And lastly, insertion after a specified node. That means it inserts the element after some specified node. Now let's run the program and understand these insertion operations practically. So in this program, we are going to perform insertion operation. So first let's start with insert to empty list. So we are going to insert a new node into an empty list. So if head is not equal to null, then return head. Create a new node and allocate memory for it. And once creating memory, assign a data. And now the new node is equal to head. And head next, that means creating a link to itself. Head next is equal to head and return head. And next we are going to perform insertion at beginning. So insert a new node at the beginning of a linked list. So if head is equal to null, then return to insert to empty list function. Create a new node and allocate memory for it. And then assign a value for a new node. So new data is equal to data. Now new next is equal to head next. So the new is the head node, return head. Next, we are inserting an element at the end of a linked list. So for that, it checks the condition. If last is equal to null, return to insert to empty list function. And create a new node, allocate memory and assign a data. And now link the address. So new next is equal to last next. Now the new node is the last next. And return last. Next we have insertion after node. So it checks the condition last is equal to null, then return null. Else we are creating here the new and a pointer variable. Pointer is equal to last next. So do if pointer data is equal to element, that means if we find the element, then allocate memory for the new node and assign a data. And now new next is assigned to pointer next. And now the pointer is assigned to the pointers next. And if pointer is equal to last, then assign new to last and return last. Next, pointer is equal to pointers next. So while pointer not equal to last next, the given node is not present in the list and return last. Next we have display function where it displays all the linked list elements. So for that it checks the condition. If head is equal to null, then the list is empty. Else it will print all the elements of a node. So now coming to the main function, here we have inserting values. There are 20, 25, 10, 15. So first insert to empty list. So we are inserting the 20 to the empty list, that is the first element is 20, and then coming to insert at end, after 20 it will print 25, and insert at beginning. So before 20 and 25 it will insert element 10, and insert after node, that means after 10 it will print 15. So now let's execute and see the output. As you all can see, it is printed in an order 10, 15, 20 and 25. Followed by that, we have a deletion operation to delete from the beginning, delete from the end and delete after a specific node. So now let's run a program. So in this program, we are going to perform a deletion operation. So we are basically deleting a node. So for that we have a delete node function. It first checks the condition if last is equal to null. That means if the linked list contain no elements, then it return. Else it will check whether the list contain a single element. So if last data is equal to key node and last next is equal to last, then free the last and assign last is equal to null and return. Next, creating a temp variable is equal to last and delete node. So here it will delete a last node. So for that, if last data is equal to key node and while temp next is not equal to last, and assign temp next to temp. So here the last next is assigned to temp next and free the last, and temp next is assigned to last. Then we are traversing to the node, or we are finding the node to be deleted. So for that we have while temp next is not equal to last and temp next data is not equal to key node, then assign temp next to temp, and if the temp next data is equal to key node, that means if you find the node to be deleted, then assign the temp next to delete node and delete node next to temp next and free up the delete node space. And then coming to the main function, it prints after deletion the linked list elements. So we are going to delete the element 15 from the list and it displays the element. So now let's execute it. So as you can see, here the linked list elements were 10, 15, 20 and 25. So after deletion, that means we deleted the element 15. So after deletion, the linked list elements are 10, 20 and 25. And finally, we have traversal operation. In this operation, we visit each and every node at least once, maybe to display all the data elements or to perform operations on it. So let's understand it practically. So in this program, the display function works as a traversal. So it traverses the every node in a linked list. So basically, it first checks the condition if head is equal to null, then the list is empty. It prints the list is empty if it does not find any node in a linked list. Then it returns. Now assign the head next to pointer so that it prints the data of every node and checks the condition while pointer not equal to head next. Coming to the main function, here we have it prints the elements of a linked list. That means after the insertion and deletion operations, it will print all the elements present in a linked list. So now let's try to execute it. So here linked list elements are 10, 15, 20 and 25. So after deletion, the linked list elements were 10, 20 and 25. Then it displayed the elements after deletion and insertion. The elements are 10, 20 and 25. So the final linked list elements are 10, 20 and 25. So with this, we have come to the end of this session on a circular singly linked list in C. I hope the session was informative and interesting. If you have any queries regarding any of the topics covered in this session, or if you require the resources like PPT, code document or anything, then please feel free to let us know in the comment section below, and our team of experts will be happier to resolve all your queries at the earliest. Until next time, thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.